Okay, now going in for the notes. Okay, this is what I have last time discussed with you, right? So we might have the final exam on 9 of June, the same time as in your class. But probably you need to add more hours. So this will start on 1:20, and maybe you need um, maybe around 3:40. Okay, 3:40. 3:40 or 3:45, maybe better to have 3:45. So it's around 2 hour, 2.5 hour, around 2.5 hour. Or just 50, I think. Make it 50. So you need to prepare time, prepare any uh, paper, pens, calculator. You can open your notes and you can prepare your notes very well, okay, for the final exam. And chapter 14 for quiz will be on, yeah, if not Friday night, Saturday morning, or maybe Sunday. But probably Saturday morning, probably. Okay. I've finished the design and I just need to copy the link. Okay. Okay, so just a little bit review on the Jacobian transformation. So whenever we have a relations between x with another variables, for example, we can define x as a function of two variables u and phi. Also, y can be described in function of two variables u and phi. We can describe the transformations. Okay, we can describe the transformation as the Jacobian. So this is called the Jacobian. So Jacobian is this. Okay. Jacobian. And we are going to have partial for each x and y. We need to partial derive both functions with respect to u and phi and make it into our determinant forms. Okay. And then we make some calculations, and that is the Jacobian value. Okay. And how we get this determinant, we get this from the cross product. If you remember how we define this cross product, it's from the area of parallelogram. Okay. So if you forget that, it's from the area of parallelogram. So we can construct our new double integral. Okay. So from the double integral, from the Cartesian coordinates, we have x, y, dA. We construct the new image. We project to the new image the s. Okay, so transform r to s, and then substitute all the x, y with a function of two variables u and phi, and adding the Jacobian here, and then du dphi or dphi du, it depends. Okay, and then we can have some explanations on the polar. Okay, we have the polar, and the polar, the r that we have, that we usually have in our polar conversion, we can also prove and make out this r through the Jacobian transformation. So the Jacobian for this xy converting to r theta, this will be equal to r. So we just adding this r as a Jacobian here. So r dr d theta. Okay, so that's for the polar conversion. And this is another explanations that we have. This is if we want to evaluate the previous example, the square to the parabolic structures, right? Okay, let me give you one more, or maybe 2 or 3 examples. Or maybe one example first. Okay, so I think I have in here. Let me check. Okay, example 3. evaluate the double integral with the region is R. The function is e with power of x plus y over x minus y dA. R is trapezoidal region with vertices 1, 0, 2, 0, 0, negative 2, and 0, negative 1. Okay, if we look on the function itself, e x plus y over x minus y. If we could imagine some integrations using the this function, I believe this is not easy task, right? It's not easy to integrate this. So, as suggested, okay, as suggested by its form, if you look at this x plus y and x minus y, how about we can define this in a new plane or a new variables? Let's say we can take u as x plus y and take v as x minus y. So if we exchange x plus y and x minus y into u and v, then we might have a chance to integrate. So what we are doing next is we need to solve this linear equation u and v in terms of x and y. So we need to make, so we need to write, okay, we need to write x in as a function of uv and y as a function of uv. This is our goal, okay, to make out our equation, and then later we can do the Jacobian transformations. Okay. Okay. Then we make out this linear equation. So u equal x plus y, and v is x minus y. First, let's just add so that the y will be cancelled, right? So we can have let me write 2x equal u plus v, or x is half u plus v, right? And then another way, we could cancel the x, right? We could cancel the x. And we take subtractions. So 2y is u minus v, right? Or y is half of u minus v. Now, since we have these relations, then we can do the Jacobian transformation. So we could write here Jacobian xy and Jacobian uv. And let's just construct first dou x, dou u, dou x, dou v, dou y, dou u, dou y, dou v. Okay. Well, it's not always u and v, but this is the most frequently variables using in the case. You can use another variables as long as you have the same structures. It's okay. So we take the partial from this x. Okay, we take the partial with respect to u. This will be half, right? It's half. It's half. Half. And for the negative, it's half. And the v, since v is having a negative sign, this will have negative half. So we will have 1 over 4 negative minus 1 over 4, or negative 1 over 2. So this is our Jacobian value. Now, to find the vertices, to correlate these vertices, so the vertices, okay, vertices xy is 1, 0, 2, 0, 0, negative 2, and 0, negative 1. Okay, this is all the vertices that we have. And then we can take this as y when y is 0, right? This is when y is 0, and when x is 0, right? And if we look on our linear equations that we have, So when y is 0, x minus y is, or let me write here, let me write so that you can focus, that we have u is x, x plus y, and phi is x minus, why I'm using bracket, x minus y. And then we have y0 and also x0, okay? Now, based on what we have, then we have x minus y. So x, when x is so u is, let me calculate here, x plus y, x minus y. So x plus y is 1, 2 minus 2 minus 1. X minus y is 1, 2, 2, and 1. Okay. So we could have x minus y is 2, x minus x plus y is 2, x minus y is 2, and for x equals 0 is x minus y is 1. Okay, now we can have the vertices for the S. So for the S has vertices 1, 1. So this is, maybe let me write in terms of u phi. So u, 1, 1. Okay. And then 2, 2. And then negative 2, 2. And then negative 1, 1. Okay, this is the new vertices for u phi. And then we can make our interval for u phi as 1 phi 2, right? So for phi is from 1 to 2, and for the u, we can make out from our equations, line equations. Or if you want to draw, let me draw first. The drawing is this. Okay. So this is the trapezoid for the vertices for u phi. So 1, 1, 2, 2, negative 2, negative 2, negative 1, 1. And we have relations also here. Phi is equal 1 to 2, and the rest is the line equations for each side. If we transform this by looking at the xy plane, this is what we have. This is from the first one here. This is what the vertices. Okay, so 1, 0. So this is 1, 0, 2, 0, 0, negative 2, 0, negative 1. Okay. Okay. Now we look on this this drawing, and you could see here. So I think if you have this kind of questions, it's better to have some illustrations so you know what kind of equation you have, the line equations, okay? Which size it will be. It's better to sketch the graph. I forgot to put in this graph first. Okay. So by the theorem, then we can have our double integral for r e. This will be projecting to s, okay, and e becomes, this is become u over v, and then adding the Jacobian value. This is du dv. And how we decide du dv is basically based on what we have here. Okay. We need to have much more approachable formulation. So that's why we are going to have the du first, okay, and let the phi becomes a constant, and then later we have dv. Okay. So we are going to integrate with respect to u first because it's, I think, easier to be integrated. Okay. Okay, now from here, we could take this and take the phi. So that's why this approach, the interval, dimensions from phi, okay, from phi here, not from this u, because I think if you want to make out from u, if you want to make u, then you could start from the left part here. You could start from here and end it here. But you are going to have some pieces, right? Some pieces. So you could check the from the first region, second region, or maybe, yeah, second region, this whole thing here, and the third region here. I believe it will be takes time to make out this three regions, right? If you want to make it into our integral. So rather than that, we can just use v as our outside integrations, okay? And then the inside is based on the functions here, the line equation here. So that's why we have 1 and 2 as outside for phi, and then the line equation is negative phi and phi for u, right? U is a function of phi. So we put there, and then e, u over v, and then Jacobian is half. Okay. Jacobian is half its absolute value. And then du will be just du and dv. Okay, we solve, take 1 over 2 outside, and then we integrate the inside. This will be integrations with this will be phi e u over phi, right? If you integrate, and then this will be from negative phi to phi dphi. So substitute to u. Let me move this a little bit left. And this will be e minus e negative 1. And then integrate with phi, it's phi squared over 2. So it becomes phi squared over 2. And this will be it's become 4, sorry, it's become 4. So 3 over 4 e minus 1 over e. Okay, that's how we do it. I think it's important to imagine the vertices. Okay, so first, okay, sketch this sketch, and also after we get the vertices for UV, also sketch this. Okay, usually this is frequently appear in many exams for this kind of situation. So I believe some procedures that you need to make sure is sketching the vertices or sketching the line, these equations, and then make appropriate transformations, consider the Jacobian value, evaluate them, and put into the double integral or even maybe triple integral that you have, and then you can compute. Okay. Now, before some other examples for this session, I would like to introduce you to the change of variables in triple integrals, which it's actually practically similar, but we have differences in row and columns for the Jacobian path. Okay. Okay, perhaps if there are any questions, you can mention in the chat box. Okay. If not, we'll wait for a few seconds until you have finished this screen. Okay. Okay. Now we go to the next session. The change of variables in triple integral. Okay, so first, as usual, we need to let the transformations as one-to-one transformations. Mapping a region, let's say a region S, in U, V, W space. Okay. Mapping onto the R region, or maybe region R. This is in X, Y, and Z space. By these correlations, so you have function of 3 variables for each X, Y, Z for U, V, W. Okay. Without any more proofing for the Jacobian, this triple integrals, because we have known the Jacobian for 2 by 2 determinants, now we will have 3 by 3 determinants, and I hope you still remember the 3 by 3 determinants. Okay. If I have the, yeah, this will be the Jacobian. So this is a Jacobian of transformations 3 by 3 determinants. Okay. And it works as the same patterns that you have in the double integral. So you have x, dou x, dou u, x, v, x, w. Okay. Y, 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 u, v, w, z, 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 u, v, w. Same pattern. And under the same hypothesis, we can construct the triple integral for this transformation S. I have, oh no, this is another example. Okay, let me just write triple integral from R with mapping to S. And then Jacobian, adding Jacobian at the end. Okay. And then this depends on situations. You can write dv du or du dv. Okay. Now, example, we can try the spherical coordinates. This is rho, theta, and phi, or phi. So it has the triple integrations, right? And it has some conversions from xyz to rho, theta, and phi. And we can first compute the Jacobian. Okay. The change of variables we can have, so change of variables. We have x is rho sine psi, cosine theta, y rho sine psi, sine theta, and z is rho cosine phi. Okay, and then we take the Jacobian. So first is dou x dou u or dou x dou rho. So we will have sine, psi, cosine theta. Okay, and then the next part is we will have the dou x dou theta. So theta will be, cosine theta will be derived, or yeah, partially derived becomes negative sign. So it will be negative rho sine psi cos, not cos, sorry, sine theta. And then we derive the sign, becomes cosine phi. So rho cosine phi, and then cosine theta. That's for the first line. The second line, we take with the equation y, we derive with respect to rho. This will be a sine psi sine theta. And this, the next one, we derive the theta. It become the cosine theta. So rho sine psi cosine theta. And the last one, we derive the sine psi. So rho cos psi and sine theta. Okay. Now the z, we have cosine psi, and then we don't have the theta, so it will be 0. And this will be negative rho sine psi. And we take this determinant 3 by 3. Okay. We could use our approach for like in the matrix. Okay. So we could take the last one here as our covectors, right? So we could use this. Remember, this is plus, right? Plus, minus, plus, minus, plus, minus, plus, minus, plus. So plus cosine psi, and then take the determinant for negative rho sine psi sine theta, rho cosine psi cosine theta, rho sine psi cos theta, and rho cos psi sine theta. Okay, and then the second one is 0, so there is no structures there. So we just go to the rho sine psi negative. So negative rho sine psi, and then construct the determinant. The determinant will be sine psi cos theta, sine psi sine theta, and negative rho sine psi sine theta, and rho sine psi cosine theta. Well, if you would like, you can also try the constructions from, if we add another line here, and we could construct this multiplications and minus the other way around. And the answer should be the same. So let's just focus here. So cos psi, this will be negative rho squared. Sine psi cos psi, and then sine squared theta, and then minus rho squared sine psi cos psi, and then cos squared theta. Okay. And this part, negative rho sine psi, this will be rho sine squared psi cos squared psi. and minus a plus rho sine squared psi and sine squared theta. Okay. Okay, we could start with this cos psi. We take sometimes to calculate the sine squared theta, cos squared theta. We can um, add both of this, so we could have negative rho squared. Okay, so negative rho squared sine psi and then cos psi, and then multiply with another cos psi, we become cos squared. Okay, and the sine squared and cos squared becomes 1. Right? And this part, we could take this. If we look here, we also have cos squared and sine squared, and it's become 1. So we could just take rho sine squared. Okay, rho sine squared, and then it's become rho squared sine theta, sine squared theta, or we could just write in terms of rho squared sine psi, sine squared psi. Okay. Why I take this separately? Because I want to make sure we have this. Okay. And later on, this will get resulting negative rho squared sine psi. Okay. And therefore, our Jacobian, for this case, our Jacobian for the spherical coordinates is negative rho squared sine psi, or we could just simply write rho squared sine psi. And by the formulations, we are getting the impressions for the spherical coordinates rho squared sine psi, and then the rho, the theta, the psi. Okay. Or if you would like to make more clear, let me take this going to the side here, and this one going through here. Okay. And that is equivalent with what we have in the previous sections about the spherical coordinates, right? But in some calculation, I think because of its own complexity for the spherical, or maybe from the triple integrations in the Jacobian, okay, for Jacobian part, I believe there is not really much variations in the question, because it's difficult to make a question for this triple integration for the change of variables. Okay. But for some simple and easily fixed type equations, I think it will be we can still observe. Okay. But most of the time, for the transformations, is we are going to have the double integral transformation. That is mostly the case. Okay, we can have much more complexity in that part. Okay. So the rest of the class, uh, I will try to discuss on some problems in chapter 15.9. Okay. Because I believe one or two examples is not enough to understand how this transformation works, especially if we have variations right in the problem set. And if you still have time at the end, maybe we could have more exercise in other section as well. Okay. Do you have any questions? You have some questions if you have. Okay, if no, then we could have some practice. Okay. Okay, let me check if I have. Okay, I forgot to mention the question. So the questions is, let me write the questions. So region R, let me write here. Region R in XY plane is given. Find equations for transformations T that maps a rectangular region S in UV plane maps onto the R, okay, where S are parallel, where S, the sides S are parallel to U and V axis. Okay, and this is the question. The R, they have variation in R. So the first R is having bounded by these equations. Okay, and the second R, the number 8, we have the parallelogram with these vertices. Then you need to describe the equations, and then this next one is having a circle. Okay, and the next one is having the hyperbolas. But let me just start with the first two questions. Okay, the first two questions, number 7 and 8. So first is we can make the parallelogram, okay, for the R. Okay, so we could take so let's say we are going to have this is 2x minus 1, 2x plus 1, 1 plus x, 3 minus x. So let's say we have point okay. So 2x minus 1 is probably around I think too small, the point too small, maybe making a little bit bigger. Maybe 1 is here. Okay, I think it's better. Now, I think the first one that can be easily to describe is 1 minus x. 1 minus x is around here. So we connect these two, maybe different color. So this is 1 minus x. Okay. And then 2x plus 1. 2x plus 1 is, we are having the x is should be negative half here. And then this will be going to connect this. Maybe moving a little bit here. Okay. And from here to here is another 2x minus 1. And 3 probably here. I need to make around here. Okay, that's probably the y equal 3 minus x. So this will be r, okay, based on the equation. Okay, if we see our line, okay, we see our line, we can have the parallel line, so we can construct the parallel line. The parallel lines we can write first. That is y equal to x minus 1 is parallel with the y equal to x plus 1. Also y equal 3 minus x is parallel to y equal 1 minus x. Okay. The first pair that we can write is, let's say we can write y minus 2x equal negative 1. And y minus 2x is equal 1. Okay. So first is the preferable relations. Okay. If we let this y minus 2x becomes our variable, we change the variable. Okay. So if we let this u becomes our y minus 2x, okay, we can map this from negative 1 to 1. Okay, right? We can have the a rectangular shape. Now, another lines that we can have, that we can make the second pair, is the, if we make the x plus y equal 3 and x plus y equal 1, okay, from the second pair. Okay, second, this is first. Now, if we let this x plus y becomes v, okay, then we can let the phi from 1 to 3, right? So if we want to transform this, or if we transform the u phi to the r, okay, this will be transformation. So we could write, and we could draw that perhaps from negative 1 to 1 for u, then this is u, this is phi. So we could draw, take one negative 1 here, 1 here, 1, 2, 3. Okay. So this will be okay. now we have this shape. So this is u equal 1, u equal -1, u equal 3, u equal, not u, v, sorry. Okay, now this is what we have, okay? And we want to construct a new transformations from here. Okay, but I think the question is just having this, right? And make sure that we have the functions. Okay? So we need to. So when we have this, so when we decide that u is y minus 2x and phi is x plus y, we need to construct a function that is describing x as a function of u and phi, and y as functions of u and phi also. Okay. So from our descriptions, then perhaps first we can set up subtractions from here. So u minus phi is equal to -3x. Or we could say 3x is phi minus u, or x is 1/3 phi minus u. And then we could set up some eliminations. So we could add u plus 2 phi is equal 3y, or y is equal 1/3 u plus 2 phi. So one possible transformations, okay, we could write here, one possible transformations is given by x equal 1/3 v minus u and y equal 1/3 u plus 2 v. Okay, basically, okay, the idea behind this change of variables is to make your calculations in the integral, in the double integral, is easier to follow. Okay, so first we need to design. We need to design how the functions xy related to up, if they are not giving any equation. So we need to construct ourselves. So they give us maybe the point. We need to construct by ourselves. We need to sketch at least what it looks like. So first, it looks like it's have this parallelogram like this one, right? And of course, if we rotate this, it could be better, right? Better approach to look the shape. And if we take some time to check some possibility on which u and v that we can make out of this xy equation, then we could have this shape. Okay, so this one is I think is preferable choice for integration. So if you want to integrate this, it's easier, right? If you want to double integrate and calculate the volume or area, it will be better through this calculation, right? Okay, is there any questions? Yeah, the question is just asking the transformation to maps the S to R. Okay. Okay. I think we can look for maybe number 9. Maybe number 9. Okay, number 9. The circles. So we have circles x squared plus y squared equal 1 and x squared plus y squared equal 2 in the first quadrant. So first quadrant, we have 2 circles. Let me make a first make a circle. So in the first quadrant, should be on the positive axis, right? So it should be on this part, right? This area. So what we have is this. The radius is the first equations is 1. I think it's not circle. Maybe just write make a circle. And then second equations is going to be here. Okay. See we can do. Okay. Okay, I think it's already centered. I think a little bit. Okay. So the region is on the first quadrant only. So I will mark this as our region R. Okay. This is 1. This is square root of 2. This is 1. This is square root of 2. So our equation is having the first circle is 1. The second circle is 2, right? So what we can do is we transform through. I believe we better to use the polar, right? The polar. So we could use xy, and then we could write like r theta, but I would like to use more general way to state this r theta as just u and phi. So let polar conversion converts xy to u phi. So we'll have the t, okay, the transformations. Uh, defined by x is u cosine phi and y is u sine phi. Okay, it seems similar to what we have in polar. And also the region here for r, we could describe this in a polar that is the radius is from 1 to square root of 2 and the angle from 0 to pi over 2. So the s, okay, the s that we want, by doing this, we could have 1 square to square root of 2 and phi is from 0 to pi over 2. So if we wanted to make it into our s region, so if this is u and phi, then if taking this 1 and square root of 2 and maybe pi over 2 around here, then this will be turns out to be just a rectangle. Okay. So this is region S. So transform this, and the S is, we can write completely. And the transformation is using the polar convergence. Okay. Okay. So we have another type of questions that I prepare. Okay, I think this also good questions. So you can also evaluate. We can start from number 18. Okay, you can start from number 18. So we have the double integrations. We have the equation that we need to compute, and we have the region R, that is parallelogram, and we have the correlations for x and u phi, and we need to compute. Okay, and you can actually directly compute the x and y, and then compute the Jacobian. Okay, first Jacobian, and then you can compute the relations. Okay, okay. Let's giving you some times to check. Okay. Okay. Anyone got the results for the number 18? So first, if you are confusing on how it's going to be looks like, how to solve this, maybe you can draw the parallelogram first, and after you draw, you can see the equations, the line equations, and you can have more correlations for this line, and making into the image of S. Okay, so this is R. Try to make the other image for the S1. So from this correlations, make another image. Okay, I think I can show you the image first. So first is for number 18. You can make a parallelogram. Let's say we have one here, one, two, three. So this is one, okay, and then one and -3 at the below. 1, negative 3, right? 1, negative 3. So right here. So 1, negative 3, negative 1, 3. And 3, negative 1. 3, negative 1. And 1, 5. Oh, it should be a little bit higher. It's not really a proportion in a proportion, but let's just write here. Okay. But then you can just take the line equations. Okay. Uh, we could have 2 over 2 is 1, so the gradient is 1. So we could take all the lines, and I think we could just take into the 4 lines, and making the lines becomes and the line is let me write, x is 1 over 4 plus v, and y is 1 over 4 v minus 3u. Okay. So we could check the x minus y negative 4 and x minus y equal 4. So if we check is it correct, or let me check. Yeah, I think this is correct. Okay, for negative 1, 3. Yeah, this is x minus 1, negative 4, and x minus 1 equal 4. Okay, and then we have this relations. Probably we can take the Jacobian first, and then later we see the connection with the line here. So this will be 1 over 4. 1 over 4, no problem. And this will be dou y, dou u. This will be negative 3 over 4. And this will be 1 over 4. 1 over 16 minus plus 3 over 16. So this will be 4 over 16 or 1 over 4. And the questions is 4x plus 8y. So 4x plus 8y we could get from this. Okay, so we could input 4 by 4 u plus v plus 8 by 4 v minus 3u. So this will be u plus v plus 2v minus 6u. And this will be results in 3v minus vu. Okay. And oh, I forgot this side. This side is 3x plus y equals 0, 3x plus y equal 8. I forgot, sorry. Uh, 1, 5, yeah, 3x plus y 8 and 3x plus 3x plus y is 0. Okay. Okay, I think complete. And next is, since we already have the pattern, okay, if we look on what we have here, x minus y, 3x plus y, 3x plus y, x minus y, right? So we could check the x minus y take as u, and 3x plus y take as v. Okay. So if we did this, then u is basically 4 and minus 4, right? And v is 0 and 8. Okay. So the equations, these are, we can convert. Let's say that we are having negative 4, 4, and 0, 8, because I think not a problem, right? We don't really have, we have a perfect rectangle, right? So we could write a constant. So 3v minus 5u, and then we have the Jacobian 1 over 4 dv du. I think if you want to du dv, it's also okay. I think this should be the same thing. And I think you can just follow up these equations. And this will be 1 over 4 dv. We could get the 3 over, write up the equations. So 3 over 2 v squared minus 5 uv, taking 0, 8, and du. So it takes time to put in 8 inside. 64. Okay, and then integrate. Oh, this is 96, right? 96. So 96u minus 20u squared, from negative 4 to 4. You can use calculator to type in and make sure the numbers are correct. This is supposed to be 192. Okay. Okay, any questions? Any question? If not, then we can move to another example. Okay, there's no questions. We can go for more practices. Okay, now let's see number 19. We have the double integral of region R for x squared PA. The R is a region that is bounded by ellipse. Okay, we have this ellipse. We have the relation between x and u, okay, and then y and v. So we could have a Jacobian directly from this. And next thing is we need to imagine how the regions actually looks like. Okay. Okay, let me move to next page to give you more close observations. So maybe if we start with the x equal to u and y equal 3v, and we can start with the Jacobian first before we construct the transformations. Right? And we know that this will be equal to 6. So we have the 9x squared. Let me check. 9x squared plus 4y squared, right? Less equal to 6 for the region. Okay, for the region. So this is the boundary. And we know that since x is equal to u, so we have if we input here, this will be 36u squared, and y is 3v. If you put inside, this will be plus 36v squared. Okay, or we could say that we have this kind of restrictions for uv. Okay, okay, and then we know that this is a circle, right? A circle with radius 1, and theta, or if we would like to directly see in terms of polar coordinates, the r is from 0 to 1, And theta is, of course, just a full circle, 2 pi. Okay, now what we are going to need is we could transform the x squared dA, transform to, let's say the r is becoming u squared plus v squared less equal 1, the region, the circle, and the x squared becomes 4u squared. And don't forget to input the 6 from the Jacobian value. And then let's write the u dv at the end. And now our du dv and all the uv we are going to convert into polar. Okay, so we convert x, y to uv and then convert to r theta. Okay, I hope you can get my point here. So the point, so the circle, since it's just a radius 1, we have 0 to pi and 0 1, and inside we define this into a polar. So u will be r cos theta and v will be r sine theta. Okay. Now for u squared, then it will be twenty-four r squared cos squared theta. Okay, and du dv will be r dr d theta. So 24. This will be cos squared theta d theta, and then 0 1 r dr, or r cubed. Sorry. And here is becomes the 1 plus cos 2 theta divided by 2. Still we have, or maybe take outside and make it into 12. So we could have 0 to pi d theta. This becomes r4401, right? And this will be 12 theta plus sine 2 theta over 2 from 0 to 2 pi. This is 1/4. We have 24 divided by 4, right? 6 pi, because the sine is 0. So 6 pi. Okay. Okay, any questions from this number 19? Well, maybe let me check another question that maybe well, I think maybe number 20 something. Okay. We could have that as well. Okay, if there's no questions, let me move to the next one. If you feel any confusions, let me know, okay? Or if you feel you lost something in the middle and you would like to discuss more, you can ask me through the Moodle or just email me. We could have one more class, okay? So since next Tuesday will be our last class, our last lectures, I would expect it you have maybe some questions or maybe specific topics that you want to discuss more. Okay, so since the finals, we will include chapter 12 to 15, but more on finals will be 15 and 14 and 15 will be a majority. This will be 12, so 12, 13 is minor. Since we have this a lot of contents, and we would have I think more discussion on 14 and 15, I would expect that you have some specific topics that you want to discuss more. Okay, so you could prepare questions. So prepare questions, not a question, but maybe prepare a topic. Prepare a topic that you would like to for discussion. For example, maybe you want to discuss more about the double integral, or maybe the directional derivative, or probably the chain rule, okay, how to describe the chain rule, or any topic that you think that you need to review more, okay? Or maybe chapter 13, maybe if you would like to know about the torsions, the curvature, right? So let me know which one you are mostly want to review, and you feel which one is that when you learn in the class or in the review and in my video it's not clear, and maybe you need to check other sources as well. And I believe that is actually true, right? If you look on YouTube, I think there's a lot of tutorial channels that are available, and I think that's also one way to learn. Okay? But what I want to take note is uh, you cannot rely only on those tutorials. So first, you need to understand the context. Okay? I'm afraid if you rely too much on the tutorials, you are mostly memorize the subject. If you memorize the subject, when you don't understand, you can pass the course, but without the context, you will feel lost. Okay, if you are given further advancement, maybe in the future courses that have some involvement of calculus. So if you are having trouble with that, this will be very difficult in the future. So my idea is understand the context, watch the tutorials from many YouTube channels. That will be helpful. So first you need to understand the context first. Okay. Okay. Maybe last two questions. Okay, last two questions. Okay, if we have integrations, maybe start with this is r, this is x plus y, e, and then x squared minus y squared, dA. R is rectangle and enclosed by this line. So evaluate this double integral. Okay, let me just give you some couple minutes to check. You could write down your answer in the chat box. Yeah, it's a little bit complex because of E, but just try your best to write the answer. And I think the last 5 to 10 minutes I will explain maybe the final exam preparations. Okay. Okay, anyone get the answer? So first, the one that you are noticing here is, I believe, this rectangle, right? The rectangle. You see the rectangle is having x minus y, right? And then x plus y. So in one side it has some line equations that is parallel, and the other part also parallel, right? So this is obvious that you're going to have some change of variables for x minus y and x plus y, right? Okay. So suggestions. So it suggests that we can let this u as x plus y and v is x minus y. Now from here, from this u x plus y, v x minus y, we can have some correlations for each x. So x is half of u plus v. And if you take this minus, then this will be 2y, and y is half of u minus v. Okay, so between these two, we could compute our Jacobian. So dou x dou u will be half of half and negative half. And this will be negative 1 over 4, negative 1 over 4 will be negative 1 over 2. Okay. So we could see from this line equation on this rectangle, we could make some conclusions that u is going to free from 0 to 3, and v is going to be 0 to 2. Okay. So we could take the double rectangle, double integral, or let me write the whole equations. This is r, and then x plus y, and then e, and then x squared minus y squared dA. And let's say we have this is 0, 3, 0, 2. Change all things here. We could exchange this becomes x minus y, x plus y, right? So this become uv, and this will become u. So this will be u, e, uv, okay? And then this will be d, u, dv, or dv, du, I think dv, du off. Forgot to write the Jacobian, it's half. And write down the dv, du. Now I think that based on what we have here, it's best to start with phi first, right? The phi, because it's easy to be integrated, right? Or else you need to use the integration by parts. So we could take half outside, and then integrate the inside e with u phi. This will be the same e u phi over u, so this will be resulting e u phi, and then this was from 0 to 2, and du. Okay. And then we plug in, still having the integral. We plug in 2 and 0, this will be 2u minus 1. This will be half, and then e 2u over 2 minus u, so 0 to 3. So this will be half 6, right? E to the 6. So half a 6 minus 3. Minus 3, and then 0 is minus half, right? Okay. And this will be resulting in 4 over 6, 7 over 2, right? 7 over 2. Take the half, so 1 over 4. E with power of 6 minus 7, right? Okay, that's the answer. Okay. Do you have any questions for our course? Oh, I forgot to announce that we might have a slight changes for percentage for grading. I hope everyone can have. I will announce in the Moodle, so I need your suggestions also, because as in previous experience in my class, when we have the online structures in the class, we will have different percentage. Okay, so if it turns out to be the first half of our course is offline, the second part is online, then the offline parts is having a more percentage. Okay, it's having more percentage than the online part. So all the quiz and also the final exam that will be online. Suppose that I will explain in the next page here. So let me explain in a quick way. So if for example the final supposed to be 30%, this is offline. The online one should be a little bit reduced. Okay, a little bit reduced. So it should be 20 to 25. Okay, the final. And the rest of the numbers, it will goes to either midterm or the quiz that is offline quiz. So we have the offline quiz, right? We have offline quiz 1 and offline midterm. These two components, getting a higher percentage. Okay, it's getting higher percentage because it's offline. Okay, I hope you do understand what I mean. Okay, it doesn't mean that I reduce your chance of passing the course, but I just want to make all scoring system fair. Okay, because I believe online is not easy. Okay, for me to supervise the test. Okay, especially when all the students they have their own conditions and variables, right? I cannot really see each one of you what are you doing in the exam, in the online exam, right? So that's why I need to make some adjustment for your scoring, and I hope you understand for this adjustment. Okay, and regarding the finals, I want to give you some explanation of what we are doing in the finals. So finals, let me just rewrite what the dates. The date 6th, it means June 9th, so Thursday. So we'll have a final, at least 2.5 hours, 2 hours 30 minutes. Okay. So suppose start from 1:20 p.m. and around 4. Let's say around 4. And I will separate this finals. Okay, we will have some several parts. Okay. So the first part of the finals, we will have a quizzes. We will have a quizzes like usual quizzes we have for short questions. Okay, for maybe 30 minutes to 45 minutes. Okay? I will guide you through all the questions, so hopefully you can follow all the instructions, okay, later on. The second part, we are using the platform called the Flexi Quiz. I will give you the link later. What you need to do is just click the link, and you need to prepare. Okay, you need to prepare paper. If you want to prepare notes, it's okay if you can open notes. You prepare also calculator if you want, calculators. So notes, books, everything that you can prepare, it's up to you. Okay, we don't have a limitation for this Flexi Quiz, as long as you don't work together, work alone, one by one. Okay. So you will give at least 3 parts, I think, in the Flexi Quiz. Let's say A, B, and C. Okay. If you finish, so maybe you still have at least one hour or 50 minutes, or 1 hour 45 minutes, or maybe 2 hours in general for all this part. Okay. So when you finish part A, you go to part B, but you cannot go back to part A. Okay, you cannot go back. So you need to make sure that you finish part A, go part B, and go part C. I will give you some roughly conditions, what will be on A, what will be on B, and what will be on C. So A, B is filling the form, filling the multiple choice, or filling the options. Okay, filling the options. So you just need to click on the options available, okay? Or maybe write some variable if you want to submit, okay, for A and B. So you just need to fill in the form. Okay. For part C, need to write on papers. So fill the form and write on papers. Okay. After finish, submit. Okay. Submit the paper through my email. Okay. Through my email. Okay. And you need to make the subject in your email as your student ID. Or in the front is final exam, and then student ID. Okay. So that's how we are going to prepare for the finals. Okay. I will give you more or another announcement if you come next Tuesday. But most of in general, this is what we have. Okay. So first is quizzes for short questions, maybe 7, 8 questions, or maybe the maximum is 10 questions, really short. The second one, using the Flexi Quiz, you need just to click the link, fill the form, take some time to prepare your paper. Okay. And after you finish all of that, the part C, the paper one, scan, send through my email. Okay. I will just make sure that you write the C in your paper. Okay. So you can have additional points if you have written on the paper and it's a correct method, but if it's the wrong answer, you still have a points, okay, for the part C. But for part A, part B, if you get wrong, then it's 0. Okay, so you need to be aware of that. Okay? So I will have this part C for all for some additional points. Okay, and please using laptop. Okay, using laptop for the Flexi Quiz. So for stability, okay, using laptop and the browser. I hope you don't have any trouble with your browser, especially if you have a lot of cache files, okay, or history. You need to clean up to make sure the browser is clean and operate normally. Okay. If not, what you can do is prepare a private browser. Okay. Private browser, or sometimes if you use Chrome, using the incognito. Because if you have trouble with your cache, the files inside the browser, you'll have some trouble when you fill in the form in the platform. Okay. Okay, I think that's all for the announcement, and we will see you next Tuesday. Next Tuesday, it's optional. You can choose to come or not. Okay, it's up to you. If you have another preparation for another finals, you can skip my class next Tuesday. It is okay. I will not count the attendance, okay, for next class. Okay, is it correct? Okay, Cassie, I will give you QR code. Okay, any other questions regarding all the details or from finals? Okay, I will explain again next week, Tuesday class, for preparation of finals. Also giving you some review on what we have in the finals. If you want to come, you can come. If not, you will prefer maybe prepare another course. That's okay. I understand your schedule, so you can skip my class next week. Okay. Okay. So if you don't have any other questions, okay, then this will be the end of our lectures. And thank you for coming. And suppose this is your last class and you don't want to come next Tuesday, that's okay. I want to say thank you for coming. I really appreciate all the students that do a lot of efforts. And I think I know some students feel that although you have materials content, you still feel that my calculus class is too difficult. The question is too difficult. I will really, I will try my best to evaluate all of you, okay? Because I know some of you are really trying their best to pass my course. So I will try my best to serve you, okay? To serve you to add some points if I can, to help you passing the course. So I will try my best, okay? So thank you everyone for coming, and see you if you want to come. And next Tuesday I will have some review. If not, that's okay. And if not, then probably this will be your last class with me. Thank you so much, and see you. Okay. So